Hi, I'm Dave Scotland and welcome to another tutorial. Today we're going to take a look at Bifrost, which is the new fluid simulation system in Maya 2015. It's a revolutionary new way of doing fluids in Maya. So a lot of people aren't familiar with exactly how to get a good simulation running. So what we're going to do in this tutorial is really do an entry level or an introduction to the Bifrost system. It's in no way a definitive study of Bifrost, and in future tutorials we'll definitely go into a lot more depth. So we're just going to use a very simple scene and we're just going to step through the basics of getting a simulation up and running. But many of the techniques, in fact all of the techniques that we're going to use today, are the exact same processes or techniques used to do much larger scenes and far more complex simulations. So we're just going to cover the basics just to get you up and running and into the new Bifrost fluid simulation system. So we've actually got a problem with our scene before we even start. You'll see that I've got a very simple scene. I've got a bottle, a wine glass, a table and a camera. So it's an extremely simple scene, but we've got a real problem if we want to use the Bifrost system. And that's actually with scale. So let me explain what I mean by that. If we just bring up our window settings preferences, you'll see down here in the settings tab that our working units are actually set to centimeters. And that would make sense that this bottle is around about 30 units high or 30 centimeters high. So if I was to draw out a quick box here, just draw it up here and make sure that it's, let's just make it 30 by 30 by 30, and you'll see that it's pretty much the right height for our bottle. So our bottle is to scale, therefore our wine glass and our table is actually to real world scale, which is what most people use when they're in a 3D environment. We've always been taught to work in a real world scale. Now when you do any particle work, that's even more important. Particles and dynamics absolutely rely on real world scale. But Bifrost is a little bit different in that it doesn't care at all about this setting. This centimeter setting really does not apply to Bifrost, and Bifrost completely ignores it. It ignores it and treats every figure that it comes across as a meter scale. Now what I mean by that, if I select this, let's draw out another cube here. I've just drawn a cube, and if we look at its settings, it's 13 centimeters by 14 centimeters by 22 centimeters. But according to Bifrost, it is actually 13 meters by 14 meters by 22 meters, because it always treats the units that it comes across as meters, and 13 is before the decimal point, therefore that's 13 meters. If I was to put in 0.5, 0.5, 0.5, you can see how small that cube has now become. That is actually, according to Bifrost, a 50 centimeter cubed object. If I was to put in a 0.1 by 0.1 by 0.1, we are now looking, according to Bifrost, we are looking at, if I zoom in here, we're looking at a 10 centimeter cube. Now that is extremely important to Bifrost. Now everything else I show you relative to creating the effect and manipulating the settings means nothing if you get your scale wrong. You see, water in the real world is extremely dependent on scale because water has weight. A meter of water cubed has 1,000 kilograms of weight. That's why when you film a swimming pool, you can't just slow the footage down and expect it to look like the ocean, because water has its own scale. And so too, water simulation has its own scale, and it must be adhered to. You can't use the same simulation algorithms that you would in an ocean to replicate a bottle pouring water or wine into a glass. The scale is totally different. The weight of the liquid is totally different. Therefore, the motion, the vorticity, and the velocity of the particles of water react very differently. So, number one, always get your scale correct. Now, if you've got to scale everything down, which we're about to do, just remember that there's a scale factor involved, and as long as you reverse that scale factor at the end of the process, you can scale everything back up to real world scale once you've completed the Bifrost simulation. So that'll make sense a little bit later on once you're familiar with the whole process. So let's go ahead, and we're going to use this cube here. What I'm going to do is actually put in 0.3 by 0.3, and that's going to be our reference cube, remembering that the wine bottle is 30 centimeters. So we need to scale the table, the bottle, and the glass down to the size of this cube so that the wine bottle is the size of the cube. And the easiest way to do that is to grab the three objects, just go into Edit and Group, and you'll see over here now that those objects are actually in this group, and we can just scale the group. So we'll come over here and start to scale this down, and the magic number is 0.01. We've sort of moved away from our reference sphere, but that's easily fixed. We'll just make sure that we've got our group selected. It's at 0, 0, so we just need to make sure our sphere is at 0, 0 in world space. And now they should be together. I'll just zoom in here now. Let's just move this down slightly. There we go. And that's looking pretty good. Now you'll find that when you work at these close ranges, because we're actually quite working in a very small environment, you may run into some problems with your camera's clipping. And if that's the case, say we're in a perspective mode here, you can actually select the perspective camera in the outliner and then just go into the attributes and into the perspective shape and just adjust the clipping ranges, which is just at the top up here. You'll see that our clipping range is at 0.1, which is actually 10 centimeters in Bifrost scale or meter scaling. So let's change that to 0.001, and that means that the camera can get quite close without clipping and we lose the geometry. So let's get rid of our reference object now, and let's start working on our Bifrost simulation. So the next thing we want to do is just set up our objects before we run the Bifrost setup, because we want to make sure everything's in the right place. I'm just going to grab the bottle, just going to pull it up. In fact, before I do, let's go ahead and create an emitter in preparation for our Bifrost simulation. Just going to go to a top view. In fact, we'll stay in a perspective view. I'll zoom around a little bit. And I'm going to create a cylinder, a polygon cylinder. Just click on the polygon tool, just draw it out and scale it up a little bit. Let's bring it over near the bottle. And what we want to do is try to get it to sit right inside the neck of the bottle. And we're just going to go into the settings, bring this down. Let's go 0.05. Get it as close as you can, and then you may need to scale it. So let's scale it down a little bit. What we're looking for is some clearance. Just come in here. We want some clearance around the emitter, around this cylinder, in the neck of the bottle. And you can see there, this is also easier to do if we switch our view to a pure front view and zoom right in there, and that way we can actually line it up with the center of the bottle there. And then we can also pull it down inside the bottle. What we want to do is just put it just inside the top rim of the bottle there. That looks pretty good. So the size of it's looking pretty good as well. We could reduce the height slightly. Let's go 0.09. Let's move it back up a little bit, and that's looking pretty good. We don't want to go down into the bottle too much, because that means our particles are actually going to emit and then fall back into the bottle and really be wasted, and we need all the computing power we can. So let's check the other angle from the right view and just make sure that it's also in the center of the neck of the bottle. So we're looking pretty good. Let's name the object. Let's call it emitter. And what we also will do is just go to the modify freeze transforms. And we'll just make sure that we might as well get rid of, delete the history there as well. So we have our emitter, and what we're going to do is link the emitter to the bottle by just grabbing it in the outline here, middle mouse button press, and then drag to the bottle. And now you'll see that the bottle has the emitter linked to it, and when we move the bottle around, the emitter will go with it. So let's go back to our perspective view and position our bottle. Let's go up and rotate into position. Something like that's going to do us. And maybe pull it back slightly, pull it down. That's looking pretty good. We might even pull it forward, try and line it up with our glass. And we will bring it down a little bit. Just make sure that glass is on the table, which it isn't. So easiest to do is a pure front view, and just make sure our glass is resting on the table. So it's always a good idea to make sure we get all this right before we start the simulation, because you can run into a lot of trouble actually amending positions of things on the fly while the simulation is actually in place. The simulation can actually struggle during that process, plus you'll be switching it on and off, on and off. It becomes pretty cumbersome, so just get it right first. Okay, so we look pretty good. Let's go ahead and create the Bifrost simulation. So I'm just going to switch over now to some textured view here. And we'll turn off the wireframe. The glass is still there, the bottle is still there. That we're just looking at the viewport 2.0 rendering, which is fantastic. It gives us our glass, and it gives us the ability to sort of see what's going on in the viewport. So I'm going to select the emitter and come up to the Bifrost pull down menu, and I'm going to click it and just simply click create liquid. Now a couple of things have happened. You can see over in the outliner that our Bifrost object has been created. Our Bifrost main node has been created, Bifrost 01. We've also got a Bifrost liquid 01, and we've got a Bifrost mesh 1. So we'll leave those in place for now. The one we're going to concentrate on for the main part is Bifrost 1. It gives us all of the settings that we need. So if we go to our attribute editor and come to our shape, you can see that we've got all of these settings relative to how the particles or the Bifrost effect or Bifrost simulation is visible in the viewport. And at the moment it's set to particles. Let's leave everything as is at the moment, but we do need to have a look at the most important setting, which is in the second tab called Bifrost Liquid Container 1. This is relating to the actual simulation, not just the display of the simulation in the viewport. That's the first tab, Bifrost Shape 1. We want this one to actually set up the simulation. The first important setting and the most important setting in the Bifrost setup is this one here, which is Master Voxel Size. It's currently set to 0.5, and as you may have guessed, because I harped on about scale for so long, that it's currently set to 50 centimeters. Now what that basically means is that the simulation is going to be based on imaginary, or they're not imaginary, but they're not visible boxes that the particles in the simulation move around inside these boxes. Now at the moment those boxes are actually 50 centimeters cubed, so they're 50 centimeter cube boxes or voxels, and inside those voxels are the particles, which means that for the simulation we want to run, that voxel size is way too big. We're never going to get anything anywhere near accurate enough. Now, zero point 0.5 is probably accurate enough for a waterfall or a raging river that's, say, 5 or 10 meters wide. This would be perfect size, and we would actually get quite a good degree of accuracy in the simulation at 50 centimeters or half a meter voxel size. But what we want is something down at the centimeter level because of the size of our bottle and glass. So let's go ahead and pull this down. I'm going to go 0.005. Now that's actually 0.5. If I went 0.05, that would be 5 centimeters. But 5 centimeters is a lot bigger than the neck of this bottle. So I actually need to go down to 5 millimeters or half a centimeter. For now though, let's go just 1 centimeter. And later on we'll change this to 0.5 and I'll show you a 0.005 and I'll show you the difference. So let's lock that in. Let's leave everything else in place. Let's not touch anything else, and let's have a look at the simulation. So the first thing we do, you'll notice this green box. That's actually the Bifrost object, but it does actually grow as the simulation goes on. You'll also see down on the timeline there's a green indicator here, and that means that when you select the Bifrost object, it's ready to render the simulation, and all we have to do is press play. So let's select it, hit play, and see what we get. So you can see now that the timeline is playing through. There's a yellow section which is jumping ahead of the green section. Now the yellow section is the forward caching of the simulation, and the green section is the successfully cached section. So when the whole timeline is green, that will tell you that the whole timeline has actually been cached correctly. Now, we're not seeing the particles, so let's go back to our Bifrost shape, and notice I'm able to move around in the viewport while this is simulating. That is because the simulation is actually taking place outside of Maya in the simulation server, the Bifrost simulation server that actually sits exterior to Maya, and that allows us to actually move around and to continue working in the Maya environment. So I'm just going to make sure that our settings are all correct here. So it looks like my particle size was a little bit too small. Just bringing that up so we can see what we're doing. I'm going to freeze this or stop the playback for now. And you can see that I'm actually getting particles coming from the emitter, but they're nowhere near usable for what we need at the moment. Now the biggest problem that I'm seeing at the moment is that the simulation is way too big because I upped the size here. So I'm just going to put that down to 0.005, which is that 5 millimeter figure. And I'm just going to kick it off again. You'll see that because I made a change, it'll play through, it'll go back to the start, and you'll notice that the green section has disappeared and it's going back to start the process again. But it actually plays quite quickly, especially if you've got a decent machine with a decent set of RAM. And at any point I can move around and see what that simulation is looking like. I'm just going to stop it there, and you can see that we're getting particles dropping through because we haven't added the bottle or the glass as collision objects yet, but we're getting the start of our process. Now if we go back to our Bifrost shape, I can increase the size of the particles. I can also change to voxels, which until you really understand exactly how they work, they really tend to be more of a mess than anything, but we'll stay with particles. And we can also have a look, change the color representation. At the moment it's set to velocity. We can go to vorticity. I'll leave it on velocity for now, but I can also tweak how the color is represented in the viewport, and you can see that it starts off slower than it finishes down here because gravity slowly picks these particles up and moves them faster as they drop. And so based on velocity, the white particles are moving faster than the blue ones, which is really handy to have a look at. So we've got our Bifrost simulation working. What we need to do is add the bottle as a deflector or a collider. So the way to do that is we highlight the Bifrost object and then we shift click on the bottle. Now we can come up to Bifrost and say add collider. Now you'll see if I select the bottle that in the shape panel there is now a new entry called Bifrost, and there are some settings in there. At the moment it's set to collide enabled, so that's what we want, and it's set to mode solid versus shell. So these two settings are relative to the type of collider it is. At the moment it is a solid object. There's no open surfaces or open-ended surfaces, so we can leave it as a solid, but just be aware that this can have a bearing. The thickness also can come into it if you're getting particles slipping through. That's one of the settings that we can manipulate to stop that from happening. So let's go ahead and select the Bifrost object again and hit play. And it's going to go through and process again, this time a little bit slower because it now has a collision object to contend with. But you can see the speed is variable. It starts out a little bit slower and then it speeds up a little bit in the simulation as it moves. And you can see that we're getting a pretty good collision happening out the front of the bottle here. So there's our particles streaming out the front, and we do have some particles that are slipping out the back. Just going to stop this now. You can see I've got some particles slipping out the back, and the first thing I like to do is just put a little bit extra on the collider's thickness. I'm just going to go 1.1, remembering that if I go too high, I'm just going to be slowly minimizing the inside of that bottle, because it's like having an imaginary force field or shield, and the thicker I've set the thickness setting, the thicker that shield is, and it starts to actually look a bit weird because the particles are reacting to something that's not really there in the viewport or in the render. So that one's, we'll leave that as is, and we'll select the Bifrost again. Let's come into the container, liquid container settings, and let's make a couple of changes here. I'm just going to, I'll kick this back up to say 0.8 just to speed things up a little bit with the renders. I'm also going to take the transport step adaptivity. This is basically about the amount of information that's calculated in between each step in time. And don't get frames mixed up with the steps, because those steps can actually be many thousands of steps in time per frame that the particles are measured inside the voxels. So, but the golden rule is that the higher this figure, the more steps I'm forcing to be calculated in the process. So I'm just going to crank this up to say 0.8 for now. And let's put the maximum transport steps up to, let's go 2000. And I'm also going to change the transport time scale. I'm going to knock it down to 0.75. Now what I'm doing there is turning it down a quarter of the speed. If I had to put 0.5 in there, it would make this simulation half speed. Now the only reason why I'm playing with time is that when wine comes out of a bottle, it can actually feel a little slower than what you would expect with water. There's a little bit more of a stickiness to it. It's more of an artistic decision rather than an actual scientifically accurate decision. So play with this setting if you want, and by the side effect, the nice side effect to slowing this down a little bit is that it gets more time to calculate on each step in the adaptivity, and that can make the process a little bit more accurate. Just going to come down the droplet threshold. The smaller the droplet threshold, the more the droplets actually break away from the main body of wine. So if you're getting way too much spray, then make this number larger, and if you're getting not enough spray in your simulation, make this number a little bit smaller. I'm just going to go 0.8. There's not a lot of spray going on with this wine coming out of the bottle. Everything else I'm going to leave as is for now, and we're going to give this another render. So the final settings I settled for, it took me probably about 5, nearly 10 minutes to just to tweak the settings and to do the odd render here and there to fine tune the settings. The final settings I settled with was a 0.003 on the master voxel size. Everything in the liquid solver attributes is kept the same. The caching is kept the same. We'll get to that in a moment. The emission, I had my adaptivity set to 1, my maximum transport to 7,000, and my transport timescale at 0.8. And I dropped the droplet threshold right down to 0.2, and also changed the surface particle density to 3. That actually allows for a lot more liquid. If you want to have a lot more liquid come out of your emitter, at least on the surface, then you increase the density on the surface. And the other thing that I changed was I made sure, if I just select the glass here, I made sure that the collision object was set to a solid at 1.5, and the bottle, selected as well, it was set to 1.3 and also a solid. And so now you'll see that we're actually starting to get something that is very believable as a liquid. It's coming out of the neck of the bottle. You can see that it's falling back into the bottle here as well, and that's quite okay depending on how you're framing it. And there's a little bit of splash there as well, but because I have my droplet size set to something quite low, that's probably it won't even render some of those splashes. So that's going to work quite well, and I'm getting a nice full glass there over a 90 frame simulation. It's about halfway done. Let's just stop it there and see what we have. So you can see it filling up the glass. Ooh. And that's looking pretty good. So the next thing I wanted to show you was what do we do from here? If I was to give that a quick render as it is at the moment, in fact that render is way too big. Let's just bring the scale of that render down. As far as rendering is concerned, you will need to know that Bifrost requires mental rate to get a decent render out of it. I'm just going to set this resolution down to say 720/405. Close that down, give it a little bit of a render. So straight out of the box with Bifrost rendering as it is with the particles, you can actually get a representation of liquid, but under close scrutiny it doesn't quite hold up to a liquid. So we'll just let that render for a second. You'll also notice down in this bottom right corner that Bifrost is actually still processing in the background, and that can be quite intensive. So I'm just going to stop that process. In fact, I'll cancel the render and I'll stop the Bifrost process, and immediately you'll hear your processor stop groaning. So do be aware that Bifrost does actually work in the background, and you will have to sometimes stop the actual Bifrost process from working. So what I'm actually going to do is I might just zoom in here a little bit more, something like that, and we'll just see if we can get a representation of that stream there. And that's probably enough. If I'll just let this little section down here run. That should probably be enough. If I hit exit there, what you'll notice if I zoom back out and select my Bifrost object, you'll notice that it actually has a material, Bifrost liquid material. It's the default Bifrost material that's part of the Bifrost system, is actually applied to the Bifrost object, which means it's applied to those particles. Or if I go back and change to voxels, then it's applied to the voxels instead of the particles. And if I just go to a shaded mode, you can see those voxels. So the material is actually applied to those voxels, and that's what we're seeing. We're actually seeing this stream in its voxel sense. I can hide the particles and just have voxels. If I hide the voxels, I've got nothing left in the simulation. But what I can actually do is come down to this section down here, which is called Bifrost meshing. Now, with meshing, I can click enable, and it will actually create a mesh. Now, it's a little hard to see the mesh, if I go into wireframe, you can see that I now actually have a mesh. Now that's a mesh in every sense of the word. It's an actual polygonal object or a geometry based object, which allows me to do just about anything with it that I can do with normal geometry. In fact, at the moment, it's based on the information that's been cached from the simulation, but I can actually go up to my Bifrost pull down menu, go into compute and cache to disk. If I click on that and give it a location, I'm just going to rename this cache directory. Let's call it 2, and I'm going to call that, well, we'll leave that as is and just leave everything else. And if I just go create, what it actually does is it starts processing. Notice it's now a blue line here. The blue indicates that it's actually caching to a list of files. Now I'll just quickly pull that up and show you what's happening in the background. You can actually see a folder called Bifrost. If you click on that, I've got bottle scene, and these are the cache files that are actually rendering at the moment. And once they've finished rendering, once this blue line has worked all the way along, then those files are going to be available for me to use. Notice this little section here in the Bifrost liquid settings is, by default, it's set to scratch cache, which is using your RAM. But once I kick this cache process off, this cache to disk process off, it automatically switches over to enable disk cache, and it points it at the location we gave it up in the Bifrost pull down menu. And that's where the simulation data is going to come from. Now, what that basically means is that the computer no longer needs to process the simulation. It's already done, and it's baked into that cache data. That allows me to then work very quickly, very efficiently, and I can place materials. I can even use that mesh that was visible there before. I can use that to drive other processes like whitewash and waterfalls and all sorts of things. I can even make a dynamic object out of that as well. So the power is really quite immense when it comes to efficiency. The other thing I can actually do is create a mesh and bake that mesh out as, if I just go to polygons here, I can actually bake that mesh out as an alembic. So if I switch to rendering, just next to Bifrost there's a pipeline cache option. If you click on that, you've got the alembic cache. So what I can actually do is take my mesh, once I've brought my cache data back in, I can take my mesh and export it out as an alembic file, which gives me even greater levels of efficiency and control. Alembic being a file format that is an open source file format that the industry is gravitating towards more and more in recent years, and is used by some of the biggest studios. It's compatible with a lot more software and more all the time. So definitely familiarize yourself with the process of alembic cache baking, or alembic geometry export, and those sorts of things. Now this is nearly worked through, and let's just stop it there. I can kill the Bifrost process down here now. You'll see that I've actually got, if I stop the timeline, that I've got an extremely high resolution mesh actually scrubbing on the timeline, because that mesh is getting its data from this cache file here. And the other thing that I can do with that mesh is play with its material. I'm just going to go into the foam settings here and switch it off, and I'm also going to come up to the diffuse remapping and maybe just change this color here. So I'm just fine tuning this color a little bit, give it a little bit more of an organic green rather than that bluey green, and that way I'm going to get a bit of a wine effect there. So I might spin that around and give that a render, and I'll pause the video and we'll do a quick render and see what we have. Now I have no lights in the scene. Obviously a little bit more specular lighting is going to help the liquid show up, but I'm just going to give this a little quick render. Okay, so there's the render, and as I said, there's no lighting. Having a background image for refraction to happen with the glass and the liquid is always a good thing. Now, you can see that we've got a very believable liquid as far as geometry is concerned, and it's working really nicely straight out of the box without too much tweaking at all. It reacted nicely to the geometry, the bottle and the glass, and we didn't have to tweak too much to get something up and running. It's a great introductory sort of exercise to do something on this scale. Familiarize yourself with the settings. Definitely go through and tweak the things to be aware of. Notice that if I select this, it's actually selecting this Bifrost Mesh 1. Now that object was created at the time that we created the original Bifrost object. Remember, it created a Mesh 1 and also a Liquid 1 node in the viewport. These didn't seem to do anything before, but they were just sitting there waiting for the main Bifrost to actually have the mesh enabled, and then what actually happens is this takes over, this Bifrost mesh object takes over, and what we should always do once we've got to this stage is to select the main Bifrost object and hide it. Just Control H to hide that, because otherwise what we're going to get in the render is actually a double up, and we're going to get two objects, and we get a pretty nasty ghosting effect that actually happens in the viewport in the render. So definitely hide the original Bifrost object when you're rendering this mesh version of your simulation. Just with the that doesn't mean we can't select it in the outliner. You can select it here. Just with the tweakable settings for mesh, definitely tweak these settings for the Bifrost mesh to get a higher resolution. You can also play with the kernel factor. Slightly higher numbers give you slightly more detail. You've also got a smoothing factor here. Everything sort of costs relation to resources, so be careful of that. The Bifrost container there, we can still make some tweaks, but we are working off a cache file now, so you do have to be careful, and you have to work out exactly where the data for the simulation is coming from once you move to this caching process here. And just the one last tip that I'll tell you before I sign off, definitely go up to the Bifrost options and make sure that your RAM is set correctly. I've got mine set to 24 because I've got 32 in the machine. By default, I think that's set to 12, and it doesn't change automatically relative to what you have. So definitely change your maximum RAM usage to suit your own machine, and you'll get a much better response on the timeline simulation process. So that's the Bifrost system. Like I said before, it's not a definitive study on Bifrost or on fluid simulations. It's just an introduction. I wanted to show you how to get into the system and get something happening nice and fast, and it's quite rewarding to actually have something happen so quickly and so accurately with minimal fuss. So definitely familiarize yourself with Bifrost. It's going to get more and more powerful as new releases come out. My estimation is that you will see a major release of Bifrost functionality before we actually see Maya 2016, because of the amount of development that the Bifrost team have been going through. It will become the basis for particle systems and fluid systems for any Maya work that you'll be doing. So the sooner you get into it and understand it, the more you'll be able to use it for your artistic work. So that's it for me. Until next time, I'm Dave Scotland. Bye for now.